Hello, new video here for a little bit of review of some concepts we've done before applying algebra to some geometry on the coordinate plane. The first thing I want to review here is the midpoint formula. If we have 2 points that both have an x and a y, the first point, here's the second point with an x and a y, we can find the midpoint between those segments by averaging each value. The x's halfway between them and the y values halfway between them. So add together and divide by 2 to average them. Find the point that's right smack in the middle, both horizontally and vertically. Here's an example of a problem. What is the midpoint of segment AB with A as 0.59 and B as -2.1? So I can go ahead and use this formula right here. I'm going to take the x values on each side, 5 plus -2, and divide by 2. And I'm going to take the y values from each point, 9 plus 1, and divide by 2, and that is going to create my midpoint. 5 plus -2 is 3 over 2. 9 plus 1 is 10 over 2, becomes a 5. You could choose to write 3/2 as a decimal, as 1.5, 1.5, comma 5. If we take a look, we've got 1.5, comma 5. That makes my midpoint right here, which I can visually see is halfway across the x values and halfway across the y values. Let me show you that. Between -2 and 5, halfway across there. Between 9 and 1, halfway across there. And where those halfway values meet is right here at 1.5, comma 5. Okay, our second formula to review is the distance formula. I want to remind you that the distance formula is simply the Pythagorean theorem. If we take the two legs and represent them as a change in x and a change in y, we get change in x squared plus change in y squared equals d squared. If I take the square root of both sides to solve for distance, it looks like this. And if we put this fully in there as how do we calculate the change in x, we subtract the x values from one point to the other, and we calculate the change in y from subtracting one y value to the other. So let's take a look at an example. Here we've got that same segment from before, AB. The way that the Pythagorean theorem is applied is similar to what we were doing with the midpoint, where I need to look at this segment right here. But instead of adding and dividing by 2 to find the middle of it, I need to know how long that is, which is why we subtract. That's why we say the change in x, or why I'm subtracting the x values, 5 minus -2. This is my change in x right there. Change in y is the height of this triangle right there. This would be the other leg of the Pythagorean theorem. The y values minus each other, so 9 minus 1. And now I've got, here's leg number 1, here's leg number 2, and I'm going to add those up, square them and add them up to find my distance squared. So go ahead and simplify all this. I get 7 squared plus 8 squared equals my distance squared. That is 49 and 64. Adding that all together, I get 113, and d is the square root of 113. That is not a simplifiable radical, so that is my final answer, unless I was being asked to round and I needed to use a calculator. If I was being asked to simplify a radical at all, such as, let's say, like the square root of 140, remember that this can be represented as two square roots being multiplied by each other. So I can look in there and see, okay, what are some perfect squares that might be helpful that I can put there that I could turn into just a regular plain old integer. Those perfect squares are 4, 9, 16, 25, and so on. I'm pretty sure that I can divide this by 4 and I get 35 on the other side. I recognize that because I could do 2 and 70, and then that could break down to another 2 and 35. So there's my 4. So 4 and 35. So I get 2 square root 35. 35 can't break down any further. I can factor it, but I can't factor it with any perfect squares. So this would be my most simple value if square root of 140 was a type of distance that I needed to break down. Slopes is the last thing that we need to look at on kind of what we can do on the coordinate plane. So again, that exact same segment. We always have rise over run. I'm going to try to stick with the same colors I've been doing before. Rise over run. Again, we're looking at horizontal and vertical components in this segment. The horizontal component, we want to know again how long it is, so it's why it's another subtraction. And same thing with the rise, that vertical component is another subtraction. Again, 9 minus 1. Slope is the only one where the direction that you subtract really matters. I started with 9 up here, so I need to be sure to start with 5 down here when I do 5 minus negative 2. When I go ahead and simplify that, I'll get 8 over 7, and that is my slope. If I wanted to start with point B instead, look at what happens with the math there. So this way I would do 1 minus 9, and then on the bottom I would do negative 2 minus 5. Turns out this is fine. I get negative 8 over negative 7. Then I would simplify out those negatives to simply land with 8 over 7. And I do get the exact same slope. It's basically saying, are you going this way or are you going this way between the 2 points? Why do I care about calculating slopes? Because slopes are helpful in recognizing what might be parallel or perpendicular. We know that the slope of this line is 8 over 7. We just calculated that a moment ago. If I was going to have a parallel line, I need to have the exact same slope as this line, and I would also have a slope, m is our algebraic notation for slope, of 8 over 7. If I had a perpendicular line, I would have to have negative reciprocal slopes, which remember is upside down is reciprocal and negative means opposite. So I would have to have negative 7 over 8. Let's take a look at what that would look like if I had just a point right here. And I would go down 1, 2, 3, 4, 5, 6, 7, and over 8. 1, 2, 3, 4, 5, 6, 7, 8. The line connecting these two, drawn best I can, is what is perpendicular to my original black segment AB. And if I wanted to show a parallel segment, say I've just got another random point here, I would have to do this slope. 1, 2, 3, 4, 5, 6, 7, 8 is my rise. 1, 2, 3, 4, 5, 6, 7 is my run. And you can see that I land with a parallel segment right there, just not super well drawn, but if I had a good straight ruler, it would be good. And there's my parallel segment with an equal slope. So these are all the tools you need to do the next couple of lessons. We calculate distance so that we can show if things are congruent or not. We calculate slopes to show if things are parallel or perpendicular or not. And we calculate midpoints because we need to know where a midpoint is if perhaps a segment might be bisected. That bisection is going to happen right in the middle, and it would happen at that midpoint. So go ahead and make sure that all of this stuff makes its way into your summary, please. The back of your properties chart is a great place to put this because your properties chart is going to be part of your summary. So feel free to add this stuff to the back of your properties chart. All right, email me or schedule an appointment if you need any help.